Good afternoon.
Good afternoon.
So I'll assume everybody saw the Avengers movie so we can talk about the ending.
Turn it on.
Yep.
So what did you think about... No, I'm not going to do that. I wouldn't do that to you. But...
Yeah, Mr. Strong, I cried when Batman died.
Yeah. Actually, in Superman versus Batman, I cried because that movie was so awful. But anyway, yeah, that was a good reason to cry. So, anyway, let's see. I will tell you this, it was kind of funny. So I go into the McDonald's for an Egg McMuffin for breakfast this morning. And so I go in there and, you know, anytime you go into McDonald's for breakfast, there's these like four old guys, you know, and they've got their, anyway, they're just like old guys. And they just sit in there and just talk and whatever. And so one of them says, hey, did you hear about that new Avengers movie? And another one says, yeah, I think it's the last movie in the whole Star Wars universe or something like that. Anyway, I didn't have the heart to correct him. It had nothing to do with Star Wars, but anyway, good times. All right, well, let's see. Is anybody absent in Moyan?
Nope.
And how about Hopi? It's like, where is everybody in Hopi?
Outside. I think they're still coming in. They're outside playing basketball.
All right. Well, let's just mark them absent right now. So they need to learn by. You'd think between August and May they would figure out when the class starts. So who do we have absent here? And Hopi, I guess. We'll look it up.
Alan, Dwayne, and Gabriel.
I think Alan's somewhere else. He's not.
Oh yeah, Alan is away.
Oh, he's in
Oh, yeah,
Washington.
close
Yeah, close to there.
It's just Dwayne and
It's just Dwayne and Gabriel, yeah.
Just Dwayne and Gabriel. Okay. All right. How about? I'll just say I can't even see you guys. Hardly. You're all fuzzy.
Oh, we're all here.
They're all there? Okay. All right.
Yeah.
Well, let's see. Let's see. So is Franco there?
I'm here.
Okay. Hey, Franco. If you get a chance, maybe after class, if you call in the talent support, they'll have to reset the camera, but usually they can fix that. It just takes a few minutes. So.
Yeah, I think it's because of our weather. It's supposed to rain here, so.
Oh yeah.
It always does that when it's about to rain.
Well, that's not cool. So, all right. Well, thanks for checking in on it. So,
All right, thank you.
You bet. Okay. Well, so today we have we're going to work on 11.5 still, and let's see. Does anyone have any questions, comments, concerns? So anyway, I had a friend that I walk with in the morning, and she went to see Avengers with her family, and she's like, okay, now I need to get with Jeff and find out, you know, what this means and what that means and so on. So anyway, it is really fun to have these comics that were in your childhood. Now they're like the most amazing movies of my generation. So anyway, so I did. Have any of you ever read any of the Artemis Fowl books? Okay, so apparently, when the first, I think the first couple of Artemis Fowl books and the first couple of Harry Potter books came out, they were about, their sales were about the same. And so anyway, so then whatever company was trying to decide which one of those they were going to make into a movie. And so anyway, so they chose Harry Potter, and of course that skyrocketed that to fame and fortune. But so then later this year, and how many years later? What was it, about 15 years ago that the first Harry Potter movie came out? So anyway, they're finally going to make the first Artemis Fowl movie. So anyway, I guess patience.
It's not even just the first Artemis Fowl movie. They're combining the first book and the second book.
Oh, really?
It's awful.
Really, that surprised me because it seems like there's enough in the first book to make a movie. I would think so. Anyway. All right. Well, let's go ahead and get started here on 11.5. My kids used to love Artemis Fowl. And so I read the first, I think, 3 of them. So, anyway. Okay, so if you remember, we were talking about combinations and permutations last class. Can anyone tell me the difference between a combination and a permutation?
In a permutation, order matters,
Order
but in a
matters.
combination, order doesn't.
That is correct. And so that's kind of the big idea here. Today, at least this part of the lesson, is to kind of read the story or read the problem and then say, does order matter here? So as you look at this practice problem, does it seem like order matters or not? No, it doesn't. It just says there are 4 students randomly selected from a class of 20. So this would be a combination. So you would do a combination of 20 things chosen 4 at a time. Okay. Now, just to kind of remind you how we did that, there were actually several ways that you could do it. You could put it in your calculator as 20C4. You could use the formula 20 factorial over 20 minus 4 factorial, 4 factorial. And then just so you know, this is another way to write a combination that we're going to use at the last part of the class. Okay? So however you want to do it, working it out by hand with the formula or putting it in your calculator, I'd like you to go ahead and finish this problem up. All right, so Hannah Z, when you've got it.
$4,845.
4,845 is correct. Okay? Any questions? All right. Okay, so now in the last section, in 11.6, we're going to have several problems that deal with playing cards. Okay, and so I just want to teach you a little bit about this one. The first one is, says a standard poker hand consists of 5 cards dealt from a deck of 52. How many different poker hands are possible? It says after the cards are dealt, the player may reorder them, so order is not important. So then how would you calculate the number of poker hands? What would you put into your calculator here?
52C5.
52C5. Okay. So because it's a combination, so again, this is it worked out, or if you just put in your calculator, you're going to get 2,598,960. So that's kind of why, poker doesn't get old, because there's so many different combinations. There's so many different hands that you could have. Okay. Now, if you're playing and it turns out, Timmy has 4 aces every hand, you probably think maybe he's got something up his sleeve there. Okay. Because the odds are getting the same hand. I mean, again, there's over 2.5 million hands there. So, okay. All right, and then I'm going to go through this probably tomorrow. But again, just so you know, if there's any questions about playing cards in this section, I just want you to know there's 52 cards in the standard deck, 2 colors, black and red, 4 suits, spades, clubs, hearts, and diamonds, 13 of each suit that go ace, and then 2 through 10, Jack, Queen, and King. And the Jack, Queen, and King are called face cards because they have a face on it. Now, speaking of practice problems, I noticed that somehow I didn't update the practice problems, and it's actually from the wrong section. So the problem should be, anyway, if you want to correct this on your paper, page 949, 1 to 81, every other odd. Not page 949, 1 to 81, every other odd. And really, this the reason why practice is exceptionally good in this section is for you to ask yourself, in this scenario, is it a combination or permutation? Okay, that's really what you need practice. I don't think you'll have any trouble, putting it in the calculator or whatever, but just, reading it and saying, okay, is this a combination or permutation? That's what you're going to need practice with. Okay? All right. Okay, so when solving problems involving counting principles, the first question you should ask is, does order matter? Because then that is going to affect your answer big time. Is it if it's a permutation or a combination? Okay. All right. So, so first, I want you to determine if this is a combination or a permutation, and then go ahead and work it out. All right. So, Denon, what do you think?
924.
924 is correct. Good job. Any questions on that? So it's a combination. The order that you pick the numbers doesn't matter. Okay. All right. So next, now we're on the very last column of the page. We're talking about binomial expansion. And so what we're talking about here is, so we have a binomial, two terms, and we're going to raise it to a power. Okay? So to the 0 power, first, second, third, fourth, fifth. Now, you've learned how to do this actually in Algebra 2 using Pascal's triangle. Okay? Now we're going to try to do it using basic patterns so that you don't have to look anything up. Maybe a little calculator work, but for the most part, we'll be able to do these in our head. Okay? So the key to doing this is to understanding it is to look for patterns. Okay? So here I have from the 0 power to the 5th power. Does anyone see any patterns here? Any patterns at all? All right. Well, then let's go through the ones that I've got. Okay. Now, if you want to, I've just sort of underlined or highlighted the basics. So if you want to just write those down, or you can write down the whole sentence here. But it says in each expansion there are n+1 terms. Okay. So what we mean by that is, see, whatever the power is that it's raised to. So like it's raised to the 3rd. Then there's 1, 2, 3, 4 terms. So if it's raised to the nth power, then there are n+1 terms. All right, number 2, in each expansion, x and y have symmetrical roles. The powers of x decrease by 1 in successive terms, whereas the powers of y increase by 1. All right, so let me show you what that's all about. So let's look at like x to the 5th. I mean, x plus y to the 5th. So we start off with x to the 5th, and then x to the 4th, x to the 3rd, x squared, x to the 1st. And you could even think of this as having x to the 0 power, which is 1. So the powers of x go down, whereas the powers of y start with like y to the 0, which is 1, and then y to the 1st, y to the 2nd, y to the 3rd, y to the 4th, and y to the 5th. Okay? So the powers of x decrease by 1, powers of y increase by 1. All right? So now the third pattern. The sum of the powers in each term is n. So like here, if I had this exponent of 4 and this one is 1, when you add them up, you get 5. So all of the exponents add up to 5, or whatever the exponent is on the outside. And then finally, the coefficients increase and then decrease in a symmetrical pattern. So here they go, the coefficients go 1, 5, 10, 10, 5, 1. Okay. Okay? So this is like the formula here. So x plus y to the nth power, you start off with x to the n plus nx to the n minus 1y plus, okay, now this is why this is in this section, is because to get the coefficients, you can do it as a combination. So NCR, that's the same as this NR. And we're going to use that to get the coefficients. And then we end up with y to the n. All right. Okay, so so now I'm going to show you like a couple of shortcuts here. Okay. Well, let's start with this. Like, let's say I wanted to do 8, choose 2. Okay, or again, it can be written like this. Okay, so here's the shortcut that's easier for the most part for what we're going to do. It's going to be quicker than even putting it in the calculator. Okay, this is how it works, is that whatever you start with 8, and then you're going to write 8 times 1 lower, and you're going to do, where this is a 2, you're going to just write 2 numbers here. So 8 times 7. All right, and then on the bottom, you're just going to put 2 factorial. So the answer is just going to be 4 times 7 is 28. Now you might say, wait, how does that work again? Well, okay, what's the long way is, see, if you think of this as 8 times 7 times 6 factorial, the 6 factorial is always going to cancel. 2 factorial is just 2. So you're just going to have 8 times 7 times 2. 4 times 7 is 28. Okay? So the shortcut is to just do 8 times 7 divided by 2. Because you can do that in your head. All right? So let's see if you understand what I'm talking about. Okay? So see if you can do this one in your head without reaching for the calculator. Oh, let's see. This is, what's the... Oh, this isn't even a practice problem. Okay, so can anyone tell me what this would be?
36.
Yeah, so you do 9 times 8 divided by 2. Well, 8 divided by 2 is 4. 9 times 4 is 36. Okay? All right, so now do that one. All right, did Dwayne show up?
Yeah, Dwayne's here.
Okay. All right, so Dwayne, what do you have?
21.
21. So you do 7 times 6 divided by 2. 6 divided by 2 is 3. 3 times 7 is 21.
Professor Strong,
Yes.
I wanted to know, how do you get the 6?
Because it's 1 lower than 7.
Okay then.
Okay, so like if it was 9, 2, then you do 9 times 8. divided by 3.
Okay.
Now, you can always put it in your calculator as well, but this is kind of a nice little shortcut. Okay, so what we're going to do is, so to start off with, let's see here. Okay, so to start off with, we're going to do the coefficients. So if we're raised to a third power, then the coefficients are going to be 3 choose 0, 3 choose 1, 3 choose 2, and 3 choose 3. Okay? Now, again, we could write them as like the NCR stuff, but you don't need to. Okay? This is just sort of kind of a more of a shorthand way to write it. Okay, now, a couple of other little tricks to help you do it in your head. Okay, whenever you have a 0 down here, that answer is going to be 1. So, like if I have 3 things, how many ways can I choose 0 of them? There's just one way. Same thing here. The last one, 3 choose 3, is also going to be 1. So if these numbers are ever the same, the answer is 1. So if you have 3 things, how many ways can you choose all 3 of them? Just one way. So the first and the last coefficients are 1. All right, next. Okay, whatever number, if you're choosing one of them, then there's that many ways. So 3 choose 1 is 3. 4 choose 1 is 4. 5 choose 1 is 5. So if I have 5 things, how many ways can I pick one of them? 1, 2, 3, 4, 5 ways. Okay, now, and then because of symmetry, see, this one is also going to be the same. So 3 choose 1 is 3. So this one's going to be 3. So there's really none of these I had to put in the calculator. Okay, or do the little shorthand trick. So the coefficients are going to be 1, 3, 3, and 1. Okay? All right. All right. So I'm going to teach. So we got 1, 3, 3, 1. Okay. Now, the rest of the way that I'm going to teach you to organize this is not in your book. And actually, I didn't know this until a couple years ago. I had a student teach me this. So, you know, I think that's pretty cool when my students can teach me stuff. All right. So if you remember, the powers of x start with 3 and then they go down. Okay. So you have x to the third, x squared, x to the first, and x to the 0. And then the powers of 1 here are going to start with 0 and work their way up. So we have 1 to the 0, 1 to the first, 1 to the second, 1 to the third. All right, so now what you do is you're going to combine, multiply, and combine each term. So this is going to be 1 times x to the third. So that's going to be x to the third. Okay, this is our answer down here. Okay. All right, then I'm going to have 3 times x squared times 1. So that's 3x squared. Then I'm going to have 3 times x times 1. So that's 3x. And then the last one, I have 1 times 1 times 1. So that's just 1. And that's the answer. Okay? All right. So let's see if you can do that practice problem. 4B. So see if you can do that one. It looks like a lot of you have already done this. That's good. All right. Gabriel, when you've got it.
I don't know.
Okay. So how about the coefficients? Did you get what these are?
Oh, that
Let's
should be
start with
one.
that.
1. Oh,
Okay. So 1 here and here. All right. What about the next one?
5.
5. So you'll have a 5 here and here. Okay. So really you only have to do one of these because whatever you get for 1 is going to be the same as the other. All right. So using that little trick, can you do this one in your head?
10. Right?
10. Okay. So the coefficients are 1, 5, 10, 10, 5, 1. Okay. Any questions?
No question.
Okay. All right. So now, all right. So Gabriel, what about the powers of x? What's the pattern on the x's? What's the first one? X to what power?
First.
Okay. No. It starts and goes down. X to the 5, 4, 3, 2, 1, 0. Okay. I think your head's still out the basketball court. I'm not sure. Okay. And then the powers of y count up. So it's going to be y to the 0, 1, 2, 3, 4, 5. Okay. And now you combine these together. And so your final answer will be x to the 5th plus 5x to the 4th y plus 10x to the 3rd y squared plus 10x squared y cubed plus 5x y to the 4th plus y to the 5th.
Hey, Mr. Strong.
Sir,
So we're like on the 5/3 one. If you do it like 5 times 4 divided by 3, you don't get 10.
okay, when you have a 3 down below, then you actually have to take it out to 3 numbers. See, whatever this number is, so you do 5 times 4 times 3 over 3 factorial. So here, let's just write that out. So it would be 5 times 4 times 3 over 3 factorial. So, which is 3 times 2. So the 3's will cancel, and then the 2 cancels with the 4, leaving you with 2 times 5, which is 10.
Okay, thank you.
Okay? Sure. I probably didn't explain it well. So I appreciate you asking that question. Okay? All right, any other... But I do want you to understand that this has to be the same as that. So you don't have to do both of them. All right, any questions on the final answer? Anything else? Okay, so just a couple of wrinkles here. So if you didn't do the binomial expansion, see, this is the kind of nonsense you'd have to do. You'd have to like multiply all this out and foil and foil and foil some more and multiply, and we're still not even done. So what we're doing in just a few seconds would take you quite a long time. Okay, and this is probably an easy one. Okay. So, couple of things, all right? If there's a negative inside your binomial, what that will do is cause every other term to go negative. So the first one's positive, then negative, positive, negative. So if you want, you can just ignore the negative and just put it in the answer. Every other term. The other thing that's a little tricky is when you have a number here in front of the variable. Okay? All right, so let me show you how that's going to change things. So here, we're going to, for our coefficients, we're going to have 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, 4 choose 4. So it's based on the exponent. Okay? So the first one and the last one are 1. The second one and the second to the last one are 4. So the only one we really have to calculate is this middle one. So could someone tell me what that would be? Four choose 2.
6.
6. So you say 4 times 3 over 2. So it's going to be 6. So you get 1, 4, 6, 4, 1. All right. So any questions so far? All right. Now I'm going to take not just x, but 2x is going to be raised to the 4th. So it's going to be 2x to the 4th, 2x to the 3rd, 2x squared, 2x to the 1st, 2x to the 0. But now when I simplify that, see, I've got to not only raise the x to the 4th, but the 2 as well. So this is going to end up simplifying to 16x to the 4th plus 8x to the 3rd plus 4x squared plus 2x, and then anything to the 0 power is 1. All right, and then now the 3 I'm going to start off with to the 0 power. So 3 to the 0, 3 to the 1st, 3 to the 2nd, 3 to the 3rd, 3 to the 4th. Now, I'm going to go ahead and simplify that. Anything to the 0 power is 1. 3 to the 1st is 3. 3 squared is 9. 3 to the 3rd is 27. 3 to the 4th is 81. And so now, as I multiply together and simplify, I'm actually going to combine the second row from each color here because I've simplified. So this row, and this row. So I'm going to have 1 times 16x to the 4th. So that's 16x to the 4th. 3 times 4 times 8x cubed. So 12 times 8, 96 x cubed. But remember, every other term is going to be negative. Okay, 9 times 4x squared times 6. That's 216x squared. Next one's negative. 27 times 2x times 4. Negative 216x. And then 81 times 1 times 1 plus 81. All right. Any questions? All right, well, let's go ahead and try that last problem then. All right, so Emily, whenever you're ready, and if you get this right, I'm going to let you all out early today. If you get it wrong, then we'll have to do more. So no pressure.
y to the fourth minus 216y to the third plus 216y to the second minus 96y plus 16.
Ding, ding, ding. Great job. All right, does anyone have a question? Anybody want me to go through it? All right, well, we're done then for today. I could go on to the next section, but hey, what are we going to do tomorrow, right? So let's just call it for the day. Any questions, comments, concerns before I set you free? All right, well, you guys have a great day. And
Professor,
yes,
we had a costume idea for you just now.
you have a costume idea
Halloween.
Yeah, for Halloween.
for Halloween? What's that?
You should be Hulk Hogan.
Hulk Hogan. There we go. There we
I
go.
like she
Well, I told a friend of mine, I've always wanted the body of Thor. So anyway, I'm not going to say anything else.
Got it.
Anyway, just we'll let that joke sink in later. But anyway, but you guys have a great day. We'll talk to you tomorrow. I would love to be Hulk Hogan. I could do that.